Dear students, welcome to Mathematics Online classes. From today onwards, we will start the new chapter, that is integrals. Integrals is one of the major chapter in the second PUC mathematics. You need to learn it well. It carries more mark and also it is new to you. Means in first year you have not studied about the integrals. In direct second year it has. What about the differentiation and all? Differentiation, it was there in the first PU. You may felt easy with that. And second year directly it is. And one more thing I want to say about the differentiation and integrations. Differentiation, it is like a luxurious chapter because there are no concepts at all. One or two methods will come. With those methods we can solve all the problems. All the problems will be way of solving have the same thing. Way of solving all the problems is similar for all the problems of differentiation. But that is not the case with integrations. In integration, way of solving the problems will be different for different problems. So, what are the basic things required for the integrals to study well? One thing is that you should be aware of all the trigonometric formula. Trigonometric formula list, I hope all of you have it. Please maintain it while solving problems on the integrals chapter. That is one thing. And next, you should be aware of all the formulae we have studied in inverse trigonometric functions. Inverse trigonometric functions chapter is also important. Those formulas will be used in inverse trigonometry. Used in integrals. That is second thing. And the third thing, most importantly, we should have the knowledge of differentiation. Those who don't know the differentiation, solve all the questions first, then integrations. Because integration is just the inverse process of differentiation. That's all, nothing else here. Such a simple thing it is. Way of saying is very simple. So, you will learn it slowly. Don't worry. And one thing, why I am saying this chapter is that much important. From the chapter integrals, in our blueprint, total 22 marks will come. One mark question, 1 into 1, and two mark questions will be there. Two mark questions. Total here, this is 4 mark. And 3 mark questions will be there, 6 mark. 1 5 mark question will be there, 5 marks. 1 6 mark question will be there, 6. Total how much it is? 5 plus 5, 10 plus 12. 22 marks will come from the chapter integrals. And after this, applications of integrals is also there. Applications of integrals totally depends on the integrals. We should be aware of all the concepts of integrations. Easily we can do applications of integrations also. Applications of integrals, I think it is a small chapter. I think it carries around 8 marks. So we will learn the integrals very well. And as 2 videos will be uploading every day, please watch all the videos regularly. Okay, coming to the definition of integration. What is integration definition? It is an inverse process of differentiation. Here, instead of differentiation, a function will be given to us. Means a derivative will be given to us. Instead of differentiation, a derivative will be given to us. We need to find the original function here. That is our task. Means, let me take the example here. All of us know that differentiation of sin x. What is differentiation of sin x? It is cos x. Sin x is given, its differentiation will be cos x directly. Now in case of integration, what happens? They will give you this cos x. What is this cos x? It is nothing but a derivative of sin x. Sin x derivative, or here with this derivative part, we need to find out the original function. That is, original function is sin x. This is integration actually. Here one thing I can say, differentiation of sin x with respect to x is cos x, I can say antiderivative of cos x is sin x. Antiderivative of cos x is sin x. Means the derivative of sin x is cos x and antiderivative of cos x is sin x. That's all. Very simple. And this antiderivative is also called as integral of cos x is sin x. This concept. Derivative of sin x is cos x, integral of cos x is sin x. That's all. Those who are good in the differentiations, they will definitely do well in integrations also. Fine. This is about the concept. And how will you write it? Differentiation of sin x is equal to cos x. Integration of cos x with respect to x. This is the integral symbol. Integral of cos x with respect to x. With respect to the which variable you are differentiating, that will be represented as a d into x. You should not think like it is another one function. D into x. That's all. It says that we are integrating with respect to the x. That is nothing but sin x plus c. Integration of cos x with respect to x is sin x plus c. Sin x plus c, I will why you are writing c, I will explain in two ways. One way is simple way. Now I am going to explain. Another one way is with the geometrical interpretation of c. Geometrical interpretation of c I will take in the next video. So now you will learn only this much. What is this c? C andre ಏನು? Suppose I have differentiation of sin x plus 6 with respect to x. What is the differentiation of sin x plus 6 with respect to x? This is nothing but cos x plus differentiation of 6 is 0. I have, this will be cos x. Here what I am doing, using this derivative part, I am finding the original function. Means if you integrate the cos x with respect to x, we should get the original function. But here that original constant value what was there we don't know. That's why what we write sin x only we will write. So to have this constant part we will put c here. That's all it is. That's all it is. This is a single concept, a simple concept I am explaining. This concept C, what does that C means geometrically, I will take it in the next part. Now you have the thing like writing C once integration completes. If once integration completes, you should write plus C, just to make sure that if any constants were there during differentiation. Suppose sin x plus 10 is there, how will you know that 10 was there? Differentiation of sin x plus 20 was there. Differentiation of sin x plus 20 is equal to what we will write? Cos x only will write. While integrating it back, you should get the original function, but we are not getting the original function because we don't know what was that. Integration of cos x is equal to, simply we will write sin x. To have that constant part, we will write c. C is any arbitrary constant. C is any arbitrary constant. Fine. Next thing is the general way of representation. General representation, how it will be. See, general representation of a function, integration of f of x with respect to x, like that we will write, which is equal to some function f of x plus c, like that we will get. What is this f of x? F of x is integral of this function small f of x. And what is this f of x is called? This f of x is called as a integrand. Integrand means the function which we are going to integrate now. And what about the x? X is a variable with respect to the which you are integrating. In case of differentiation, you have stated that differentiate the function with respect to x, differentiate the function with respect to y, like that. Here dx is there, means that x, it indicates integrate with respect to x. And what about the function? This function we got after integrating it. Or differentiation of this function will be f of x. And what about this c? C is nothing but any arbitrary constant. C is any arbitrary constant. Okay, this much concept is enough to go with the problems of this integrations. So now let us go with the listing out all the properties. First thing is that what you do, you make a column of two columns. One column is for differentiation, another one column is for integration. Here I will write derivatives, here I will write integrals. It is just an inverse process of each other. Integration is the inverse process of differentiations, that's all. See, first thing, what is differentiation of x raised to n? Differentiation of x raised to n with respect to x is equal to n into x raised to n minus 1. All of us know that. In the same way, I want to write the formula for integration of x raised to n. What we do? See, with this concept I can say integration of n into x raised to n minus 1 is equal to x raised to n plus c. That is not a big thing. Let me differentiate using this formula. Let me differentiate x raised to n plus 1 by n plus 1 with respect to x. What is its differentiation? Its differentiation is this n plus 1 will be constant, it will be kept as it is. Differentiating the function x raised to n plus 1, it will be, I am using this formula, n plus 1 into x raised to n plus 1 minus 1. N plus 1 get cancelled. X raised to n. See, if I differentiate this x raised to n plus 1 by n plus 1, I am getting x raised to n. Means, if I integrate this x raised to n, I should get x raised to n plus 1 by n plus 1. That is the concept. I can write the formula. This is first one. Integration of x raised to n with respect to x is equal to x raised to n plus 1 by n plus 1 plus c. Now, coming to second one. What is the differentiation of e raised to x with respect to x? This is nothing but e raised to x. Then what will be the integration of e raised to x? That is again e raised to x only. Second case. Second one. Integration of e raised to x with respect to x is equal to e raised to x plus c. Finished. Coming to third. What is the differentiation of x with respect to x? Differentiation of x with respect to x is 1. Now we have integration of 1 with respect to x is equal to x plus c. Plus c is must and should. Why plus c is must and should? Suppose I have here a differentiation of x plus some constant c with respect to x. What do we write its differentiation? Its differentiation is 1 plus 0 we write. That is nothing but 1. While integrating, we should get back the original term. That's why we write x plus c. Next, fourth one. Suppose I have differentiation of k into x with respect to x. What happens to the differentiation of k into x with respect to x? K we can write out of the differentiation. That is k into differentiation of x with respect to x. Differentiation of x with respect to x is 1. K into 1, this is nothing but k. Means, suppose I have integration of k with respect to x. What we write? Differentiation of integration of k with respect to x is, k is a constant. I can write out of the integral. K into integration of 1 with respect to x it is. That is nothing but k into integration of 1 is x. Integration of 1 is x. K into x plus c. Integration is completed. Plus c you should put. If you forget to put the plus c, if the question is for 1 mark will be deducted. If it is for 2 mark, again 1 mark will be deducted. That is, c is must and should. There is two types of integrals also. That is, one is definite integral, another one is indefinite integral. What is indefinite and what is definite? Indefinite means c value we don't know. C can take any real number here. So such type of integrals we call indefinite integrals. What about the definite integral? Definite integral means c has a particular value, like c is equal to 1, c is equal to 2, c is equal to 3, like that. C has a particular value. If c has a particular value, then we call that type of integrals as a definite integrals. So what it means? Definite integral, indefinite integral, what it means actually? That concept you will understand well with the concept of geometrical interpretation of C. Simply I will say it once. Plus C is there means C, depending on the values of C, I can have more number of curves. If I am writing the graph of this x plus 1, x plus 2, x plus 3, x plus 4, like that, how many curves it is indicating? It is indicating n number of curves. That is indefinite integrals. If c is equal to, there is a particular value, like c is equal to 0 or c is equal to 1, any one particular value is there means it will represent only one curve. So such type of integrations we call definite integrals. That is the difference. That one I will explain with the geometrical interpretation. You don't worry. Now I am listing out all the properties, all the formulas of integrals. You have to be careful with all those. Next, fifth one. What is the differentiation of a raised to x with respect to x? Differentiation of a raised to x with respect to x we have studied as a raised to x into log a. A raised to x into log a. Now I want to find the integral of a raised to x. What happens to the integral of a raised to x? To derive that formula, let me differentiate a raised to x by log a. A raised to x by log a with respect to x. Here x is variable, a is constant part. Fine. We will keep this 1 by log a as it is, that is outside we will keep, and the differentiation of a raised to x. What is the differentiation of a raised to x? That is nothing but a raised to x into log a. Log a get cancelled. We have a raised to x. Means what I can write? I got a differentiation of a raised to x by log a as a raised to x. We can write integral of a raised to x as a raised to x by log a. That is formula number 5. Integral of a raised to x with respect to x is equal to a raised to x by log a plus c. Differentiation of a raised to x is a raised to x into log a. Integral of a raised to x is a raised to x by log a. How this happens? I have derived this one. Differentiation of a raised to x by log a. Like that we have derived. Okay. With that we have derived around 5 formulae. Next, formula, sixth one. What is the differentiation of log x with respect to x? Differentiation of log x with respect to x is 1 by x. That's all. What I told you? I told you that integration is just the inverse process of differentiation. So suppose I have integration of 1 by x with respect to x. What we will write? We will write this one as log x plus c. Finished. Now coming to the seventh one. What is the differentiation of sin x with respect to x? Differentiation of sin x with respect to x is cos x. With this concept, I can write integral of cos x with respect to x. Integral of cos x with respect to x is nothing but sin x plus c. Coming to eighth one. What is the differentiation of cos x with respect to x? Differentiation of cos x with respect to x is minus sin x. Now, eighth one here, integration of sin x is equal to, integration of sin x with respect to x is equal to See here, differentiation of cos x is equal to minus sin x. Now integration of sin x is there. What happens? Minus you multiply on both sides. This becomes differentiation of minus cos x. Differentiation of minus cos x is nothing but plus sin x. So integration of sin x is minus cos x plus c, you should write. Coming to ninth one. Differentiation of tan x. What is the differentiation of tan x? Differentiation of tan x is a secant square x. Very easy now. Integration of secant square x with respect to x is a tan x plus c. Now, 10th one. Differentiation of cot x with respect to x. Differentiation of cot x with respect to x is minus cosecant square x. All of us know this. In the same way, what will be the integration of cosecant square x with respect to x? Here multiplying on both sides, we have differentiation of minus cot x with respect to x as cosecant square x. Integration of cosecant square x with respect to x is minus cot x plus c. Coming to 11th one. Differentiation of secant x. What is the differentiation of secant x? We know its differentiation as a secant x into tan x. Now I have the 11th formula of integration as integration of secant x into tan x with respect to x is equal to secant x plus c. 12th one. Differentiation of cosecant x. What is the differentiation of cosecant x? We have this one as minus cosec x into cot x. I can write the 12th formula as integration of cosecant x into cot x with respect to x is equal to minus cosecant x plus c. Problem number 13. Now coming to the differentiation of inverse trigonometric functions. Differentiation of inverse trigonometric functions we have studied. Differentiation of sine inverse of x. What is the differentiation of sine inverse of x? That is nothing but 1 by square root of 1 minus x square. I have formula number 13 as integration of 1 by square root of 1 minus x square with respect to x is equal to sine inverse of x plus c. Okay, 13 formulas we wrote. Going to 14th one. Differentiation of cos x. Differentiation of cos inverse of x is nothing but minus 1 by square root of 1 minus x square. Now I have 14th formula, integration of 1 by square root of 1 minus x square with respect to x is equal to minus cos inverse of x plus c. You observe the formula number 13 and the formula number 14. What is happening here? 1 by square root of 1 minus x square into dx. This is sine inverse of x. Here also integral of 1 by square root of 1 minus x square into dx. I am writing minus cos inverse of x plus c. Then you may ask the question here like, sir, is that sine inverse of x is equal to minus cos inverse of x? So that is the beauty of integral here. How? One thing you may observe, one concept I will say here. If differentiation exists for a particular function, then it has only one value. It is only one value. If integral exists for a particular function, it may have many solutions. Integration, there is no fixed answer, there is no fixed only one solution. We may write 2 to 3 answers for each problem. Differentiation, if it exists for a particular function, it has unique solution. It has only one solution. But integration is not like that. It have many solutions if it exists. Okay. And again, these two are same. These two are similar. How these two are similar? We will say. See, already we know integral of 1 by square root of 1 minus x square with respect to x is equal to sine inverse of x plus some constant. That some constant, let me take it as c1. And next, we know the formula in inverse trigonometric functions. We have derived that sine inverse of x plus cos inverse of x, which is equal to pi by 2. With this concept, I can write sine inverse of x is equal to pi by 2 minus cos inverse of x. Pi by 2 minus cos inverse of x plus c1. This is a constant part. This c1 is also constant part. Pi by 2 plus c1. Pi by 2 plus c1 is another one constant. Constant can be anything here. Pi by 2 plus c1, we will write it as c. So, minus cos inverse of x plus c is another answer here. So, with these definitions, for this single problem, you see how many answers we are observing. We are observing two answers. Constant part can be anything. Constant can be anything. We don't need to worry about the constant here. One constant is getting added with another one constant, it is become a third constant. No worry. Okay. That is about formula number 14. Going to the formula number 15. We know the differentiation of tan inverse of x with respect to x. What is differentiation of tan inverse of x with respect to x? That is 1 by 1 plus x square. Now, as it is inverse process, formula number 15, 1 by integral of 1 by 1 plus x square with respect to x is equal to tan inverse of x plus c. 16th one, differentiation of cot inverse of x with respect to x. Differentiation of cot inverse of x, all of us know, that is minus 1 by 1 plus x square. I can write here formula number 16 as integral of 1 by 1 plus x square with respect to x, which is equal to minus cot inverse of x plus c. Again, you can observe here, for the single problem we are getting two answers. This follows the concept what I explained. Formula number 17 we are going to derive, that is differentiation of secant inverse of x with respect to x. What is the differentiation of secant inverse of x? We have the formula as 1 by x into square root of x square minus 1. Now, formula number 17, that is integral formula, 1 by integration of 1 by x into square root of x square minus 1 with respect to x is equal to secant inverse of x plus c. Formula number 18, differentiation of cosecant inverse of x with respect to x. We know this as minus 1 by x into square root of x square minus 1. Here it is again 1 by integral of 1 by x into square root of x square minus 1 with respect to x is equal to, I can write minus cosecant inverse of x plus c. These are all the formulae which are basic formulae. Here many formulas will come. You need to be aware of all those. Make a list of all the formulas we are studying in the integrals and revise them again and again. With this, we will go to the problems on this. Okay, before going to the problems, let me say properties here. This is the concept of indefinite integrals. Properties of indefinite integral. Three properties are there. Like properties you have treated for differentiations. In differentiations you have treated properties like UV properties, U by V properties, U plus V, U minus V, like that you have treated. That U into V, U by V, all those will not those will not come here. Simple, U plus V and U minus V, like that. First property is that suppose I have differentiation of integration of f of x with respect to x. See, both integration and differentiations are acting at a time. Then what happens to this? We may observe here, as integration and differentiation both are inverse procedures to each other. Simply I can cancel this integration and differentiation, write it as f of x. That's all. Original function, whatever is there, that function will be. And instead of that, suppose I have integration of differentiation of f of x with respect to x is that, and whole integration is with respect to x. Now here what happens? Here you should write that f of x plus y plus c comes extra here, means the integration will be operated later. First differentiation happens, then followed by integrations. So integration happens in the sense plus c you should write here. Okay, that is about the first property. Now second property is that suppose I have integration of f of x plus or minus z of x, whole integration is with respect to x. Now can we take this one as sum of two integrals of difference of two integrals? Yes, definitely. First one, integral of f of x with respect to x plus or minus. Plus is there, is plus, and minus is there, is minus. Next one, integral of z of x with respect to x. Like that we can do. Derivation of all these properties is not at all required. We are not going to do here. Now third one, suppose I have integration of k into f of x with respect to x. Means for a function integrand, some constant is multiplied. Shall I take this constant out of the integral? Yes, definitely. This can be written as k into integral of f of x with respect to x. Thank you. You revise this video again and again before attending the next class. In the next class, we will take problems on this. Thank you.